Hey everyone, it's Mr. Vargas here once again, looking to help us out with homework 8.1 function tables. So we are now starting a new chapter in our textbook, and the title of that chapter is Functions and Inequalities. These two words are very important words in mathematics, and over the next couple of weeks we are going to be exploring what exactly functions and inequalities are. To get us started out, let's kind of get a general idea of what a function is. So, function, F-U-N-C-T-I-O-N. And basically what a function does is it takes an input, changes that input somehow, and creates an output. Okay, and this is where the change occurs. And this is the function itself, the rule of the function. It will change that output. A lot of people like to refer to this as a machine. A machine. And I know this is kind of abstract, so maybe let's look at something a little bit more relatable. Let's say you take gasoline and take that gasoline and you put it into a lawnmower. Let me try drawing a lawnmower really quick. You guys know my drawings are usually really bad. Okay, it's not terrible. But you take the gasoline, you put it into the lawnmower, and then what does the lawnmower do with that gasoline? It outputs it, or it throws it out as exhaust or smoke. So here you have an input, which is your gasoline, your rule, your function machine, which is your lawnmower, and then that changes that gasoline into exhaust or smoke. So let's go ahead and look at a few examples from our homework, just to kind of get you guys a better idea. Alright, problem number one. Problem number one. And I really like how we're starting out with function tables here, so let me draw a quick table. Okay, and you've got your input here and your output over here and your rule goes right in the middle. Let me make some space for that. Your rule goes right in the middle, and they tell you that the rule is 3x plus 5. So a lot of this is going to be like, if you guys remember, evaluating expressions, where you take a number and then you plug it in and see what you get out. This is very similar to what we did last chapter, or sorry, the chapter before, where we were evaluating expressions. For number one, they give you some inputs. So let's see, 0, 3, and 9. And basically what you're doing with these inputs is you're replacing them with the letter x. So 3 times 0, remember a number next to a letter means multiply, plus 5. This would be 3 times 3 plus 5, and this one would be 3 times 9 plus 5. And then you guys can all figure out what happens when you plug that stuff in. For the first one, 3 times 0 is 0, plus 5 gets you 5. For the second one, 3 times 3 is 9, plus 5 is 14. And for that last one, 3 times 9 is 27, plus 5 makes 32. Alright, you've successfully completed your first function table. Let's go ahead and look at number 3. Just because it's a little bit trickier, you kind of have to work backwards. So here is our function table. Alright. Once again, our rule goes in the middle. And this time they tell us it is x plus 2. That's our rule. Our input on the left, which is your x, and your output on the right. Okay. So this time they're actually giving us the outputs, and they want us to work backwards to figure out what the input was. So here it was 2, 3, and 8. So now we are thinking, what plus 2 equals 2? What number plus 2 equals 2? You can use some solving like we did last chapter, but you're going to probably figure that one out in your head. It is 0. 0 plus 2 equals 2. So your input here should have been 0. And I'll do that in blue, or red actually. 0. Okay, so that's it. Let's go down to the next one. We've got x plus 2 equals 3. So what number plus 2 equals 3? Well, we can erase that x and replace that x with just 1, right? Because 1 plus 2 equals 3. So your input should have been 1. Okay, looking down at the next one. So what number x plus 2? X is our variable, it's our unknown, we're trying to solve it. And what number plus 2 equals 8? If you guys remember, we can subtract from both sides of the equation, and you get x equals 6. Okay, so that means our input, let me back all that up, our input should have been 6 plus 2. 2 was already there. 6 plus 2 equals 8, so our input here was 6. Alright, and that successfully completes that function table. Let's go ahead and look at number 5. Actually, I'll jump down to number 6. Let's look at number 6, and then we'll be done with this video. Bella rollerblades 8 miles in 1 hour. The function rule that represents this situation is 8x. Okay, so I already know we're going to have some type of function table here. Might as well set that up. Okay. And your rule goes in the middle. Input and output. Okay. So let me go back to the word problem. Bella rollerblades 8 miles in 1 hour. The function rule that represents this situation is 8x. Beautiful. The rule is 8x. Okay? Where x is the number of hours. Oh, so we can make a little note here. This is going to be hours, and the letter x is used to represent the hours. Make a table to find how many hours she has skated when she has traveled 16, 24, and 32 miles. So miles is actually going to be our output, or our distance traveled. And they do, they put the letter y. And we can explore that more as we go through this problem. Then graph the function. Ooh, so we're also going to have to use some coordinates here. Okay, let's figure this out when there's 16, 24, and 32 miles. So 16, 24, and 32 miles. Alright, so we're working backward to find our inputs for these results. So what did we have to plug into our rule to get an output of 16? In other words, what times 8 equals 16? 8 times x equals 16. So what got me that? That would probably just be 2, right? 8 times 2. Okay, so I can replace that. 8 times 2 equals 16. So 2 is your first input. And then 8 times what number equals 24? Oh, that would probably just be 3. 8 times 3 equals 24. And then 8 times what number equals 32? Well, that would just be 4, 8 times 4. Okay. So our input there was 4. Alright, we've got all of our points figured out, and now they ask us to graph it. They ask us to graph this function. So here we are actually going to be using our input and output as coordinate pairs. And this is something that's very common in math. You're going to be doing this for the rest of your math career in middle school and high school. So if you remember, our coordinates, and I apologize for writing in the 8 box, but if you remember, our coordinates go x, y when we are plotting points on the coordinate plane. So here, in my first example, my x is 2 and my y is 16. So that's going to be my first point, 2, 16. Okay. And then in the second example, I had 3 and 24. So that's my next set, my next ordered pair, 3, 24. And then my last example, I had 4 and 32. So x is my 4, my output y was 32. And we'll explore later that these are called independent and dependent variables. But that's a little too much for this video. Okay, let's go ahead and quickly graph these points. Whoa, that was cool. Let's go ahead and quickly graph these points. 2, 16, 3, 24, and 4, 32 on the coordinate plane that they give us. I have to recreate that really quick. And it looks a little bit like this, where these are your hours. 1, 2, 3, 4, 5 hours. And this is your x direction. And this is your y direction, which is miles. And here they go by 5s. Let me zoom in on that. So that'll be 5, 10, 15, 20, 25, 30, 35. Okay. So this doesn't need to be 100% accurate as long as we get a good sketch. So the first point was 2, 16. So let's go ahead and graph that. We go over 2, start in the middle, go over 2, 1, 2, and up 16, which is just a little bit above that 15. So if we're close, that's fine. So maybe right about there would be 2, 16. Alright, and then the next one was 3, 24. 1, 2, 3, up to 24. Would be right underneath that 25. So maybe right about there. And that's the point 3, 24. Okay, and then the last one that we had to graph. Let me make a little bit more room for that. Okay, and the last one we had to graph was 4, 32. So 1, 2, 3, 4, up to 32. Just a little bit above 30. So it's probably going to be right about there. Alright, and we've graphed our points. And some of you can kind of see that this is actually going to create a straight line that goes up. Let me draw that one more time. Your function creates a straight line that increases by 8 miles for every hour that you are skating. Alright, that's enough for this time. Good luck on the rest of the assignment. Thanks.